Hello again. In this video, I'm going to be showing you how to use a couple of regression algorithms in Weka using your Java. So we're still using the Weka API. Now, I'm assuming again that you're familiar with what regression is, but briefly, regression is the process when we build a model where the class variable is numerical. So before we've done classification where the class variable is categorical or nominal. In this case, for regression, the class variable is numerical. I'll repeat, if you're not familiar with these algorithms, then you can go to my YouTube channel and find my playlist. It's called Data Mining Algorithms, and in there I explain several algorithms for regression and for classification. I explain how they work. Now let's go to the documentation. We go to the package weka.classifiers.functions, and we find Gaussian processes, isotonic regression, and several algorithms. One of them is linear regression, class for using linear regression for prediction. So we're going to have a look at this one, and there's another one here. Maybe you can pace regression. You can have a look at that. You can try it if you want. SMO for the support vector machines. We've seen this before, but we have a regression version here. SMO reg for regression implements the support vector machine for regression. So let's have a look at linear regression. It's quite simple actually. So class for using linear regression for prediction uses this criterion for model selection and things like that. Several useful functions in this, several useful methods rather than functions, plenty of them. We can have a look. And the good thing about this is actually quite simple to use. It's very straightforward. So let me go to my Eclipse, create a new class. You don't see this on your screen, but I'm creating a class the usual way. We give it a name, regression, and then I have prepared the code, so we just paste the code, and this is the usual way we have as we have seen before. We import the required classes. Notice here we have classifiers.functions.linear regression, and then we load the data set. Always remember to set the class variable. So where's the class index? Usually it's the last one, but it depends where it is in your data set. But always remember to use it before set that up before you actually create the model. And then we just declare a variable of type linear regression, and then we build the model by using the method build classifier. So these are regression algorithms, but they fall under classifiers in Weka. That's how Weka was designed. So we just use the method build classifier. We pass it the dataset, the instances, object, and the linear regression model is built. If we print that model out actually, then it can print us out the actual model, the actual formula. So let me save. Notice here now I'm using QDB1. If you remember, we used QDB, it's numerical, and then it had the first column or the first attribute was ID. So we removed it using the filter, and we have actually saved this. So if you view QDB, it has this one compound ID if you remember from before, but QDB1 we removed it, and now we have only 4 attributes, and the 5th one is the class. And the good thing here is that all of them are numerical, so it's going to be straightforward for us. We don't need to do any pre-processing. We just execute build the model. When it finishes, as you can see here at the bottom, it prints out the model. So this is the result of this printout statement here, system.out.println. I just pass it the model name, and it prints out the formula. Let me try another model for SMO, for the one I mentioned earlier, for using the support vector machines for regression. Import SMO reg, and then just build the model. Let me comment this out as we have seen. So I'll comment this out quickly, and then we just declare a variable of type SMO reg. We build it, and we just print it out. So we print out another model now for the SMO reg. Execute, and as you can see, it's slightly different than the linear regression one. In fact, it even gives us number of kernel evaluations. So this is the model built using SMO reg. Now you must have been asking by now at least 2 questions. The first question is, how do I evaluate the performance of a classifier, the second, or a regression algorithm? The second question is, well, I've built a model, but how can I use it? If I have data where the class is not known, or where the value that I want to predict is not known, whether the value is numerical or categorical, well, how do I use these models to make those predictions? This is what I'm going to show you in the coming few videos, so stay tuned. Thank you very much for watching, and I'll see you in my next video.